Okay, here we have a kinetic rail space propulsion. Normally if you have a rocket, it shoots out fuel in the back, and you have a limited amount of fuel in a rocket. So the way the thrust works in a rocket is you propel mass through the backside. In this case is the gases that come out of the rocket. That is actually the mass that is propelled into space, because you need some sort of mass to be propelled at high speed through the back. In other words, to propel it forward. So this kinetic rail space propulsion system is just another way of replacing the rockets in space, because just like a rocket, it propels the mass toward the back, which is a gas, and that creates thrust. And the same concept, this vehicle right here, for example right here, has two wheel sets on top of the rails, and each rail's got a two rail system. So it's a pair. This is one pair, and this is another pair. So it's rolling on these rails, going this way. So what it does is propelling the double sets of rails going this way at high speed. So it's propelling the two sets of rails backwards. And just the way that it works in the rockets, it's propelling mass toward the backside, and that equals thrust this way in propulsion forward. So that's the way it works using kinetic energy. You're thrusting mass toward the backside, high speed, okay? And that's what makes it go forward. This is all kinetic stuff. Second drawing, as its first one, it's going this way, starting. Second one, it's up here already, and it's going to make a one revolution set or lap, okay? So once you go on the third drawing, see, and it starts rotating. See, this is the other lap here. It's rotating the wheels. So now these are the original one, and then once it's done, it'll go back to the same one. So this is the same drawing. This is set one drawing, second set drawing, third set, which is you got these rail system sets on each side, and they're on the back because the wheels are rotating going this way, if you can see that. So the wheels got to rotate from here, got to go back this way, same way on the other side. The wheels got to go this way and go this way. So it's going to flip the rail system, and this is the fourth drawing. It's still in the process of flipping the rail system. The wheels are still going this way, and it's moving the rails closer until it becomes one set again, and then we had to start over again. So it's the same process. So this is, let's say this is a starting point. Number one, this is number 5. Then it starts this way, halfway, and then it goes over here, and then it's the rail set starts flipping to the other side because the wheels start going this way. The wheels start going this way, and it starts moving the rail system closer. This is the other side. It's still in the process of closing in because the wheels are going this way. The wheels of the spacecraft is going this way, and then you have a starting point right here, and then it goes fast again. Basically what it does, when it does that, going this way fast, is pushing the two sets of rails to the backside of the craft. So you pushing these two rails, right? Pushing it back at high velocity, and since you're pushing mass, this is a vehicle pushing mass in the backside of the vehicle, you create thrust in space. But in this form, it's kinetic. The only difference between this and a rocket in space is basically rocket is limited fuel. Once the fuel's gone, it's gone. And this kinetic rail space propulsion, using a solar sail, not a solar sail, a solar panel, you have unlimited propulsion as long as you have the sunlight, or unless you have nuclear power, you still have a way to propel forward at high velocity. The way this works, this is just an example. Example only. Every lap, I wrote this wrong. For every lap rotation, let's say one lap takes 1 minute. So every one lap equals 1 mile per hour. So, I mean, basically, if it goes more than one lap, it's going to be more than 1 mile. For example, let's say you make one lap in 1 mile. Yeah, so one mile for one lap. 1 hour is actually 60 miles or 60 laps. So 1 hour equals 60 miles. 1 day equals 1,440 miles. 1 month equals 43,200 miles. 1 year equals 525,660 miles. So basically, just using this number, and this number is just an example, because we don't know how fast or how slow this concept is going to be, depending on how they design it. Basically, it's accumulative. So let's say you're going 100 miles, and then every minute you add another mile. So now in 1 minute plus, you get 101 mile. 1 minute, plus 2 minutes, you got 100 miles plus 2 miles, and so on. So every minute you add another mile, and it's accumulative, everlasting. As long as it's doing the double lap rotations, it accumulates 1 mile per lap per minute. It adds to the velocity. So if you're going 100 miles, you add to that. If it's going 500, you add to that. Whatever velocity it's going, it's adding every minute. So basically, every year you could add 660 miles per hour. That's just on a slow scale. If you have rotations, in this case I only have 1 lap per minute, but let's say you had 6 laps per minute, and there'll be higher velocity. So you wouldn't have 525, 660 miles. You will multiply that by 6. So that's what I'm trying to say is the faster rotation of every double loop lap. In this case, I'm only adding 1 minute per lap, but let's say 1 minute per 6 laps. That adds faster velocity. But basically, it's a kinetic, and it's velocity. It's on every minute. It goes faster and faster and faster and faster until infinity. Until basically it doesn't have a power source to go, or it breaks down basically. But the concept's pretty good. Basically, in theory, it could be used with nuclear power. It could be used for interstellar space, because it's going to go faster and faster. But obviously, even for going to Mars, it's going to be very fast, because you still have solar panels that could be attached to the space vehicle and harness the solar energy and transfer that into these wheels or kinetic rail space propulsion system, and you can travel to Mars in a couple days, couple weeks, because remember, every minute it gets faster and faster and faster and faster and faster and so on. So it's accumulative velocity, this kinetic rail space propulsion. And obviously it's a whole kit. You need the vehicle with the 2 rail systems. So that's the way it works, because as it goes forward with the wheels, rotation is pushing the 2 sets of rails back at high velocity. When you push back the rail system at high velocity, you create thrust through the backside. In this case, instead of being fuel or gas, it is actually real mass in the form of solid mass, instead of being a mass of gas. That's the only difference. You're using solid mass instead of gas and form of mass. So that's the only difference between these two. So there you go, folks. Kinetic rail space propulsion.